extension 1. Let's do this view, full page. So this is just an extension 1 topic. It's more about the exponential growth and decay, so let's get to this. Not yet. Yes. Still not yet. Mr. Alpha is here. Which would be the exponential growth and decay questions. Nope. No. No. Yeah. Okay. Let's start with exponential growth and decay, and then we'll get to the rates of change questions that are numerical and algebraic instead of the modeled versions. So let's have a look at this one here. At the beginning of 1991, Australia's population was 17 million. At the beginning of 2004, the population was 20 million. So 1991, population was 17. 2004, the population was 20 million. Assume that the population P is increasing exponentially and satisfies an equation of the form P equals, the population equals, A E KT, where A and K are constants, and T is measured in years from the beginning of 1991. Show that P equals AEKT satisfies dP on dt. Now, this first one, this part I, in fact, all of these questions for exponential growth and decay, give or take, are very, very similar. So I is usually this, double I is usually this, triple I is usually this, and then IV is usually this. So you pretty much can assume what the question would be for these styles of rates of change questions, which is why it's the first one I'm starting with. So the question says, show that P equals AEKT satisfies dP on dt. All right, so if you've got P equals AEKT, you have to differentiate, right? dP on dt just means differentiate dy on dx. So we've got to differentiate the exponential. So dP on dt. The derivative of an exponential is an exponential, so that doesn't change. Then what you've got to do is differentiate the kt, which becomes k, and you multiply by that, and your a doesn't change either. So that's just a number. Numbers stay as constants. So exponentials, ekt, become exponentials, ekt. Kt, differentiate kt becomes k. There it is, a times k, ekt. But it said it has to become somehow dP on dt, so the derivative has to be k times p. Can you guys see that p is actually AEKT? P is AEKT. So this is p. So isn't the answer just k times p? Do we get that before I move on?
Yeah.
Anybody not get that? Differentiating, we're okay with that as well now? For the exponentials. Let t equal to 0. Well, oh sorry, what the? That's the answer. Double A. What is the value of A? All right. What is the value of A? Well, the idea is you've got to use these two pieces of information. When time is 0, so 1991 at the beginning, you're assuming the beginning is when you're starting, so time is 0 at the beginning of the year. Population is 17 million. When time is what? How many years from 1991 to 2004? 13 years. So when t is 13, population became 20 million. So it says what is the value of a? To find a, you always want to get rid of your exponential. So you would let time equal 0. Then you'll have p equals a. Let me just write the formula again. There it is. Population at time is 0 is 17 million. So 17 mil times 10 to the power of 6 is million. A, e to the power of 0. E to the 0 is 1. So what does a equal to? 17 million. Find the value of k. To find the value of k, you use your second condition when time is 13 and population is 20. So find the value of k. Again, what do we have now? We've got p equals a e kt, right? But now we also know when time was 13, population was 20 million. So we've got 20 million is equal to 17, 10 to the power 6 e k. I know time was 13 years, right? So when time is 13, our population was 20 million. When time is 0, population was 17 million. Okay, back to our solving for k's. What's the first thing I get rid of? 17 times 10 to the power of 6, divide that over. So that's 20 million divided by 17 million, which is 20 over 17. What do you do to both sides? Remember, you're solving for k.
Log.
Log both sides. So you got log of 20 on 17 equals, bring the 13k over, and then log and e cancels out, and then you're solving for k, and you're done. Plug that into your calculator. So you can pretty much tell this bit here is not harder than the 2-unit stuff that we were doing last week. The only difference in extension 1 is that you have to actually do the derivatives bit, where advanced kids don't. But otherwise, the rest of the questions are the same. There it is, and last one. Wait, do you guys still copying that down? Okay, last one. Predict the year during which Australia's population will reach 30 million. So it's obviously saying find time when it's 30 million. So 30 times 10 to the 6 is equal to A. A is 17 times 10 to the 6. E, K we just found 0.0125. But like we said last week, you write it, you use the unrounded answer. So maybe shift store A to K. All right, divide by 17. And then log both sides. And then divide by 0.15125. You start to get pretty used to that. So the answer is log 30 on 17 divided by K, which gave me 45.43. It says predict the year during which Australia's population will reach 30 million. Which year would that be? See, you didn't get full marks. The year is 1991 plus 45. 2036. Predict the year during which Australia's population will reach. If you just found 45, you do not get 2 out of 2. You only get 1 out of 2. Okay. All right. Any questions? Is this that much harder than what we were doing last week? To anybody? All right. Let's do another one. Yeah, I don't want to do that one. Seems too straightforward. Exponential decay, which is just negative. Yeah, let's do this. HSC 2017. Oh, that's pretty recent. Let's do that one. And then we'll do this. I think that's done. Okay. Let's go 2017. 2-unit HSC question 14. Carbon-14 is a radioactive substance that decays over time. The amount of carbon-14 present in a kangaroo bone is given by C of T, carbon at time T, is equal to AEKT, where A and K are constants and T is the number of years since the kangaroo died. I. Show that C of T satisfies dC on dt equals kc. What's the first thing you do? dC, differentiate. So dC on dt equals, bring the k down, leave everything else the same. What does AEKT stand for? AEKT stands for C equals kc. You got yourself 1 mark. Double I. After 5,730 years, half of the original amount of carbon is present. So what does that mean? When time is what? What equals what? For half of the original amount of carbon-14 is present. What would C equal to? Half of the original amount. Azra, do you have an idea? Original amount.
Is it
Yeah?
half A E K to the power T? K T.
Close. It's just half of A actually.
Oh, okay. Oh, yeah, that would make sense.
A is the original amount. So if you go back up and you have a look at what we just proved up here, when time is zero, this bit here is always going to be 1. So your A is always going to be your original amount, original population, original bacteria, original height, original whatever. So A is always going to be your initial conditions. So your original amount is just half of A. It says show that value of K is this. Okay. So formula was C equals AEKT. So C is half A equals AEK, which we don't know, 5730K. All right. What do we do? We're solving for K. What's my next step? Divide by A and then
log
both sides and you get rid of E. You're left with this, and then
you divide by 5,700.
You're hoping that when you plug this into your calculator, it says something with a negative there. Let's have a look. Log 0.5 divided by 5730. I got negative 0.00012. Is that what we had? 0.0012. You're happy you got yourself 2 marks. And why do you know it should be negative? Greg, why do you know it should be
less than log 1?
So, yes, yeah, fair enough, but
It decays.
It's
So,
decaying, so your K has to be a negative K anyways.
Yep.
So if that K there was negative, then this value here would be positive. So it gives you negative K still. It's decaying. You're losing. You're losing. You know, in this case, you're losing carbon-14, or you're losing population size, or whatever the ID would be. Okay, easy. Triple I. The amount of carbon-14 now present in the kangaroo bone is 9% of the original amount. So what does that mean? C equals 9% of the original amount. Find the number of years since the kangaroo died. Give your answer correct to 2 sig figs. And we do it again. So 0.09a. Is anybody not understanding what we're doing here? Whoops. T you don't have. K you have. Negative 0.00012 time. A's cancel out. You log both sides. This comes down, then you divide it by negative 0.00012. But I'm not going to use this. I write this, I don't use it. I'm going to use the whole answer I had for K. So my answer is like this, log 0.09 over answer. Whoa, what just happened? When I find the number of years, kangaroo died. I got 19,000 years, which I don't see is wrong, but I don't know why he's written the answer is 870. Why have you written that, Hubert? 19,906 years. Can anybody check my math? Make sure I haven't done anything wrong.
Yep.
You got that as well?
Yeah, I did.
9% of the original amount. Yep. And then find the number of years since the kangaroo died. Yeah, 19,000 years. I don't know how he got 870. I've got to tell him about that one. What question is this? Example 15, page 23. I'm talking about that. Definitely not that. 19,000. And you know that can't be right anyways, because it took 5,500 years just to get to half of the original amount. So to get to 9%, it's even going to take longer than 5,500 years. So that's all right. I mean, it does say to 2 sig figs, so you would not get 4 marks. 1, 2, what's it, to 2 sig figs has to be 20,000, right? So you go like this, 1, 2, look at the 9. This 9 makes 19 into 20, so it becomes 20,000. 2 sig figs. The amount of students I've seen lose marks just because of the final bit that says 2 sig figs is insane. I would say greater than 70% of students at this level lose their mark with 2 sig figs, more than their calculus and everything like that. Okay, we'll do one more. Maybe I'll let you read it for a sec, absorb what it's saying, and then we'll just do it together, finish it off. This was from 2013. Question 16. Question 16 is the last question of the paper with the new version, with the multiple choice. So that means pretty much band 6, and it means greater than, let me have a quick read of it. Yep, greater than 95. Especially with that. So if you're a band 6 student, that's great. This is more for the 95 plus students. The students who will be getting 95 plus will be able to answer all of this. That's how question 16, these style of questions were. Anyways, have a quick read. Okay. Are we ready? So just maybe write down if you, in your books, maybe you want to just write the question, the paper, 2013, two unit. Ah, why is this even in the extension 1 booklet? This should be really easy then for you guys. But anyway, 2013 2 unit HSC. Question 16. Trout and carp are types of fish. A lake contains a number of trout. At a certain time, 10 carp are introduced into the lake and start eating the trout. So that means the trouts will be decreasing, and obviously the carps would be reproducing and increasing. That's the idea. As a consequence, the number of trout N decreases, like I just said, according to this. Where T is the time in months after the carp are introduced, the population of carp P increases according to this. So the population of your carp is increasing according to this. This looks like what? dP on dt equals kp, where P equals, AEKT. Right? Do you guys get me? Do you guys get that, what I'm writing there? Isn't that what we were just proving? When P is this, dP on dt became constant times P. So when you have dP on dt, it's just that. That means you know now K is 0.02. Okay. All right, let's start this. This one's for, what was this again? This is trout. This is for the carp. Okay. How many trout were in the lake when the carp were introduced? What do we do? How many trout were in the lake when the carp were introduced? What do you think? So we want to work out how many trout. We want to work out N. What's the only thing that's stopping me finding N? Come on, someone, give it a shot. You won't be wrong. You got to get rid of time. What does time equal to when they were introduced?
T.
T equals what?
Time.
Yeah, I know that. What number will it equal to when it's introduced? What are you going to assume time is? 0. N equals 375. When it's introduced, it's like that. Time is 0. So 375 take away 1. There was 374 trouts when time is 0. Double I. What letter? Stefan, what letter are you solving for? When? What letter would you be solving for?
What? When will the population trout be 0?
When the question says when, what letter would you solve for? When I come up to you and I ask you, when do you want me there?
I can't hear you. You're breaking up for me.
If I come up to you and I ask you, when do you want me there? What would your answer be? In terms of time. So if it's asking when will the population of trout be 0, you're trying to find T, time. When will the population of trout be 0? So what does N equal to? 0. Because the population is 0 now. Okay, what do? You're trying to solve for T. What do you want to get rid of?
The E.
No, not yet. Oh, what you mean? Plus it over here?
Yeah, put it on the left side so it's positive.
Yep, and then?
And then
now you want to get rid of the E? Yeah.
Yeah, log it.
Log it. This will cancel out. You're left with 0.04T equals log 375. And then?
And put ln 375 over 0.04 to get T by itself.
log 375 divided by 0.04, you get t is 148. So when will the population of the trout be 0? Well, if you said 148, it would not be right because it won't be 0 at 148. It'll be 0 at 149, or exact around that point there. So when t equals to 149 months. Do you get that when I say that?
Yeah.
At 148 months, you haven't reached 0 just yet. It'll be like 0.1, but not 0. So when it's 149 months, you would have reached 0. Triple I. Sketch a number of trout as a function of time. So sketch this. Okay. There's your x value and there's your y value. All right. Stefan, any ideas of how to sketch this? Think of it in terms of y equals 375 take away e to the power of x. If that helps. Anybody know? Yeah.
The y-intercept is at 375.
So
So
y.
it's going to be like a.
We'll be going down.
It will be going.
You assume the y-intercept is at 375. It's actually not.
Yeah. Oh yeah,
When time is 0, you found that it was at 374.
Yeah. Sorry.
So it's actually at 374. But anyways, the way I would be looking at it is a normal exponential is this way.
Yeah.
A negative exponential is this way. And that would be a -1, right? But then you're going to shift the whole thing up 375. So you've got an asymptote at 375. It cuts at 374. And that's the answer. Do we get that?
Yep.
So, IV. So it's saying eventually, somewhere here, your time, when time is whatever that is, which we can work out, you will have no more trout. Right? You will kill off all your trout. So you start off at 374, and eventually you're going to get no more trouts. When is the rate of, when? What letter are we trying to solve for? It's important because, you know, a lot of students tackle these and go, I don't even get what it's saying. I don't know how to do it. And usually that already tells you the answer. When? Okay, at least now you know you're finding time again. Is the rate of increase of carp equal to rate of decrease of trout? Rate of increase of carp. What does rate of increase mean? Well, that's not your normal function. Your rate is the derivative. So rates of increase or rates of decreases are your differentiation. Rate is just your gradient. All right, your gradients were your rates of increases or decreases. Right, this is a slope. That was your rate that it's increasing by. Or if I told you you make $20 an hour, and I don't know, and you have $100 call out fee. Your equation is y equals 20 times, h plus $100. 20 times h, and depending on how much h profit, let's say, depends on what your h is, the more profit you make, but 20 is your rate that you charge. B. You never thought of it like that? Rate is a rate you charge or you get paid or whatever, right? But that's also your gradient. Y equals mx plus b. So your gradients are your rates of increase, and gradient is done through calculus. So what's your rate of increase? Rate of increase is dp on dt, which is 0.02p. So it's saying when dp on dt is equal to dn on dt. dn on dt. So I've got to find dn on dt. So dn, well, let's just write it again. There it is, 375. And I've got to find dn on dt. That is negative 0.04, negative 0.04, and then e 0.04t. You guys can see that? 375 disappears, and then you bring the 0.04 down, negative 0.04, e, keep it the same. That's what your dn on dt is. That has to equal to dp on dt. So
Wait, Sam, could you repeat how you read 371 and how that got replaced?
say that again.
Could you repeat that last step, please?
Yeah, so 375, what happens to when you differentiate that?
It's 0.
0, so that's gone. And then what's the derivative of negative e 0.04?
I get it.
Yeah. And then what we're trying to do now is dn on dt has to equal to dp on dt. So dn on dt must equal to dp on dt, but we're not going to use this dp on dt, right? You might as well use this one so you can have your exponential function in there. So I think, anyways, but let's have a look at it. You're going to have what? Like dp 0.02, and then times a. So p is a e kt. Therefore, p equals a e 0.02t. dp on dt is equal to 0.02 times p. So dp on dt is equal to 0.02 times a e 0.02t. And we already know what is a equal to? Oops. What is a equal to? A is equal to 10 because it says at a certain time 10 carp are introduced. So that means initially you had 10 carp. So it's 0.02 times 10 e 0.02t. You guys get that? I might redo that question because I've gone all over the place with that. So 0.02 times 10 e 0.02t. So let's redo that one. The question says, when is the rate of increase of carp equal to the rate of decrease of trout? So the first thing is, let's say the rate of decrease of trout. So I've got to first differentiate this and find the derivative of trout, which I did. So dn on dt equals that. The next one says rate of increase of carp. I know that's already been differentiated, so the rate of increase of carp is there, 0.02p. Now, I know that is actually k times p. K times p. So I know that p equals to aekt. How do I know that? Because that's the whole point of exponential growth and decay. right? It's what we proved before. So you've got to memorize P equals AEKT, which means K is 0.02 because they gave you that. And when they're saying 10 kappa introduced, that means when time is 0, you actually already know what A is. A is 10. So dP on dt becomes 0.02 times P, but P, you already have what A is. A is 10 in P. And yeah, end up with this particular result. So the hardest bit of this, I think, would have been more knowing what P is, and then obviously knowing that K is 0.02 and that A is 10. And that's why it's a 95 plus. You've got to actually know KP means P equals AEKT. You've got to really know your stuff instead of, let's say, 90% students, band 6 students only would not know that very well. That usually comes into the fine details. Okay, then you get to this solution here, and obviously you're just going to solve for t. So if I had to solve for t here, what would I be doing? I would, personally, I would just first get rid of this 0.02 times 10. What's that? Times 10 should give you 0.2. And then I would bring it to this side. So I would probably divide these two to this side, just because, for no real reason, just because I can. And then so once I divide these two onto that side, it'll look like this: negative 0.2 E 0.04 T equals E 0.02 T. All right, here we go. 95%. Who wants to try it out? You can't log yet because you've got t's on both sides. And plus you've got this negative 0.2 times by the e. You can't have that. If you want to log it, you can't cancel out anything. Just log of all this monster. It's not good. Come on, someone give me an ID. And just think of your basic algebraic laws.
Would you bring down the power?
You're not allowed to because of it's not a log. If it was log of 0.
Maybe
Yes,
move it over.
Say it again.
Maybe move these negative 0.2 e to the power of 0.04 t to the other side.
How?
Like subtracting it and moving it to the other side, or is that not possible?
I think you're saying you're right and you're saying you're wrong at the same time. Say it one more time. What am I trying to do?
You're moving the negative 0.2.
Right.
Yeah, like the whole thing.
The whole thing.
Yeah. And then like.
No. Nope. Eventually you'll get stuck with the same issue that I'm trying to solve here.
Maybe make e equal to like e to the power of 0.02 t to like a pronumeral.
No.
Okay.
You're getting close, but no. Like that last idea wasn't right. Your first idea was kind of on the right track, but I mean, in algebra, if I wrote it differently, you would have never said to do that.
Yeah.
So try to think what I'm trying to get you guys doing without me writing it, because I can write it and then you guys will just go, oh, cool.
Yeah.
You're trying to solve for what? Just keep that in mind. Every time you're trying to do something, you're like, all right, I'm trying to solve for this. What were my rules when I'm trying to solve for t? I'm trying to solve for t. What must happen? What must I do?
You try to make the bases equal.
Make the bases equal. They don't necessarily have to be, because if you had 0.2 equals, let's say, e of t, their bases are not equal, but you can definitely log both sides now, because you now know logs. Before you were trying to make the bases equal. Once you know logs, you don't have to do anything like that. I kind of hinted the answer there. But anyways, continue. Keep giving me your answers. It's good. I want to solve for t. I want to solve for t. What's my rules if I'm trying to solve for t and I've got something like this? Come on. Just basic equation rules I'm talking about, not even log laws or anything like that.
Factorize?
Factorize would have been exactly what Greg was saying. So eventually you're going to get stuck with something. So it would work, but it doesn't need to be factorizing just yet. But anyways, to factorize, let's get this point. To factorize, what must they be on the one side? Correct? So you would have plus this whole thing, but still not just factorizing. It's not factorizing. Come on, we're almost there. Almost. I feel like they're there. Look, if I gave you this, what would you have said to x to the power of 5?
Will you divide the right side by
Are
minus
we splitting the
0.2?
powers by?
Wait, 1 sec. Wait, say it, Stefan.
Divide the right side by 0.2.
Oh, no.
Are we splitting?
Negative 0.2.
No. Wait, Greg, what'd you say? What are you saying?
Are we splitting the powers by any chance?
Splitting the powers. No, I don't know about that. Wait, Stefan, think about it. You're very close. But just think about
Would you
what
divide the exponential over?
Yeah.
Okay.
Stefan,
Yeah.
you're so close, man. Why do you want to move this guy over? That's just a number. It doesn't have t's. You would divide this guy over here. So you're going to be left with negative 0.2 equals e 0.02t over e 0.04t. So then that way at least you've got t's on one side. That's your golden rule. Your t's have to always be on the one side. You can't have letters on two different sides. Then what do you do when you have an exponential, or when you have a base divided by a base? What do you do to the powers? You would subtract them. So it's 0.02, take away 0.04, which should just give you 0.02. So negative 0.02t. Now what do you do to both sides? Now you would log it, and then there's a big problem. The problem is the fact that I'm going to log this negative here. It's going to cause some issues. So give me 1 second. Give me a second. Yeah, no good. No good. What's the problem?
There's always a negative on one side.
Say that again.
There's always a negative on like either side.
Yes, but what's more of a negative rather than this side here? I can't log negatives. So there's a problem there. Can't log a negative. Okay, so get rid of that line. Unfortunately, we got too happy here. Didn't work out. Believe in it. It's still going to be this. But let me just make sure. That is what I would do, right? That and that, yeah. Yep. Right? Yes. Oh. Ah, come on. Come on. Okay. Let me make sure I didn't do any calculation errors here. So we did 0.02 times 10, 0.2, and then I did negative 0.04 divided by answer is negative 0.2 of E. Ooh, interesting. Interesting. 0.02t Base, you subtract my calories. Interesting. Then there must have been something wrong.
Also, Sam,
Yes.
negative 0.04 divided by 0.02 is negative 2. That's just a small error.
But then times 10. There's still times 10.
Oh, nope, didn't see that. No mind.
dn on dt equals negative 0.04 e negative 0.04 t. Yeah, I don't think I've done that one wrong. Negative e equals just the dp. Did I get this bit wrong? dp on dt equals 0.02 k. K is increasing, so that should be ekt. Yep, that is definitely increasing. And then K is that, and then P is 10. P is 10. Am I sure about A is 10? Let me read this. A lake contains a number of trout. At a certain time, 10 carp are introduced into the lake and start eating the trout. That's right. So when time is 0, carp, the amount of carp that you start with is 10. The population of carp increases according to this. That means the population of carp is equal to 10 E kt, and as it's increasing it becomes k times p. Yep, I'm happy with all of that. And then 0.02 times 10 e 0.02t. 0.02 times 10 e 0.02t. Interesting. All right. So I've got to think, what have I done wrong? Have I done something wrong? Right. What if I bring this guy over to this guy? So 0.04, so I get negative 0.2 e 0.02t equals to 1. But then when you're going to do 1 divided by negative 0.02, 1 divided by negative 0.2 gives me negative 5. That's still a problem because when I log this negative 5, I can't. Am I doing something wrong here? When is the rate of increase of carp equal to the rate of decrease of trout? Rate of decrease. Rate of decrease of trout. That's already a rate of decrease. This is decreasing, this is already increasing. Where am I going wrong here? Alright, let's have a look at our good friend Hubert's answers and see where I'm going wrong. Doesn't have his answers on there. All good. Oops. 2013. 2013 HSC Advanced Math. Question 16. Zero 0.04 E0, wait. P solves the equation. 0.2 E 0.2 T. What do I have? Yeah, 0.2 E 0.02 T. So we've got that. 0.04. We've got negative 0.04 E 0.04 T. Why? because the rates are to be equal, so this negative can't equal to this positive. There, of course. That's it, right? For the rates to be equal, they're going to be equal. They've got to be in absolute values. Okay. So I didn't do anything wrong other than the fact that for them to be equal, I can't have the negative there. Fair enough. Okay. Not a big issue then. Ugh. What's happened? So back to what Stefan said, it wasn't wrong. It's just that I probably didn't start it very well. For the rates to be equal, you can't have a negative exponential equal to a positive exponential. The module, they have to be absolute values. You can't have a negative equal to a positive number. It just won't obviously work out. So it is just the positive case, which is 0.2 equals e 0. What did we say? Negative 0.02 t. Then you log both sides. And then divide by negative 0.2. And that should give us 80.47. So what's the question say? When is the rate of after 81 years? Or they leave it, so they don't mind, you leave it as 80.47. Or if you can round up, that's at HEC. And there you go, look, you get to at least see what your 1 marks are for, 2 marks are for, 3 marks. Last one. When is the number of carp equal to the number of trout? Well, that's easy. It's just, again, when would P equal to N? What is P equal to? P is equal to A is 10, so 10E 0.02T, 10E 0.02T, N was 375, take away E, 375, take away E 0.04T. All right, now again, I'm going to solve for T. How do I get rid of this guy now? How do I get rid of this one? You're not going to do what we did up here, which was divide. What would you do? You'll just plus it, right? So that will be 10E plus E. Now what do you do? It's what you were saying before, Greg. And I think Mariette as well, you said the same thing. What do you do now? You want T only by itself, you only want one of them.
Factorize.
If you factorize, what's going to happen? So yes, that is exactly what I wanted you to say. So you would take the smaller one out, which is that. But what's going to happen still? Are you allowed to say this equals to this? When are you allowed to say that? This equals to this. What must this equal to for you to be able to say that?
0.
It must equal to 0, so factorizing still doesn't help. Now, this is where I want you guys to think like that 95% that I'm talking about. Think of Band 6 students, 90. Think outside the box. What are you going to do?
Divide by 10.
Divide by 10. I don't like it because this is going to be over 10.
Bring the 375 to the other side.
Okay, yes, that is part of the solution. Beautiful. Well, let's write it. Oh, sorry. Let me make sure I've got it out. It's that and that, right? Yes. 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 Should be. Right? Yeah. Okay. All right. Yes. You're here. And let's wait. Let me just make sure. Was that the last question of the paper? 16B IV, 16BV. Oh no, geometry was. So that was second last. So that was A. The derivative of the function, the line, find the function. Oh, that's easy. Simple integration. So second last, and then the last one was geometry, similarity, which is out of the syllabus now for you guys. But second last. So that one there, yeah. Let's go back to it, have a look, and just think outside the box. You got to think like them. 95. What are we going to do? Think of the whole topic, and then think of exponentials, think of what you've learned, think of why you even brought this 375 over to the left-hand side in the first place. What have you usually done? You try
Is
to
it meant
practice.
to be like a quadratic?
Why? Do you see something?
Like, are you supposed to substitute something for E 0.02 T and stuff? Is it one of those?
Yes, it is.
Yeah, but 0.02 squared is 0.0004, which doesn't.
Ah,
I don't know what I'm
touche,
doing.
touche. But you're not seeing it. No. Okay,
Oh.
you pretty much said it. This is actually at the beginning. I'll just rearrange to show everyone now. So it is actually a quadratic. It's the hidden quadratic that I usually have mentioned. But look, when I see 1, 2, 3 terms, and I especially see a constant, I'm already thinking quadratics. You guys got to start getting used to that. Then most students that are able to see it do go into that little pitfall that you just went into. They're like, oh, but then that when I square it is actually not 0.04. The problem is you're thinking of squaring it, but what you've forgotten is that is
Oh,
actually.
you could switch the thing. Yeah, okay.
It's actually when it's
You can
squared. No, when it's squared, what happens? You don't square it. What do you
Wait.
do?
What am I doing?
When you square something and it's got power to power, what are you going to do?
I'm gonna times them. Oh no.
Yeah,
Yes.
so actually
I
it does.
remember doing this. Yeah.
It actually multiplies by 2 instead of square it. Otherwise, I mean, that would have been t squared as well, no problem. It just times in by 2. So this, you let u equal to e 0.02t. Now, of course, that becomes u squared plus 10u minus 375. And then you just solve for u. And then you bring your exponential back. Since I've got the answers, I think we can safely copy it. You solve it, you get negative 25 and 15. So thank you. U equals negative 25 and 15. And then of course you bring E 0.02t as negative 25, which won't ever work because you can't log the negative. You'll do E equals 15, log both sides, and then divide by 0.02. So something like that. E log 15 on 0.02, 135.5.4. And then of course, as always, you have to answer the question. The number of carp and trout are equal in the 136th month. So it says in which month. You got to write that. You won't get full marks. So let's go back. Good work. There you go. So it's not so much rates of change as you can see. It is a bit more, equations than anything else. Once you start to understand the wordings, the rates of change bit is not that hard. Okay, any questions? Okay. modified exponential growth and decay. All right. Yep. Yes. We can do this. Let's do it. Some Newton's laws of cooling. Beautiful. Let's do it. And is that the last bit for growth and decay? Yes, it is. That's just your reference sheet. Cool. So the last bit of exponential growth and decay, which should be pretty much just extension 1 now. So, I guess another application of exponential growth and decay is what's called Newton's laws of cooling. And the idea of Newton's laws of cooling is that it will be an exponential decay or growth, but you also have an extra constant term. And that constant term is usually surrounding air temperature, let's say. So if I take a chicken out of the oven, I know that as soon as I take it out, which was, let's just say 250 degrees, but the constant air temperature is, let's say 25 degrees, I know that that chicken will start to cool until it reaches my air temperature, which is 25 degrees. And it's doing that at an exponential decay. And that's what Newton's laws of cooling are, and that's what this extra term is. So the difference to what you've just learned, which was dP on dt equals kp, is that you've got an extra air temperature or constant air temperature. So it's dP on dt equals k, p minus a, where your p function is now a plus b e kt. A is constant air temp, and then B is just your initial value like it was before. Okay, so let's have a look at a question. It makes a bit more sense. So scenario: boiling kettle, initially 100 degrees, is allowed to cool to room temperature set at 22. Assuming the constant room temperature, the temperature T of the water will be limited to, obviously what would happen? It'll be limited to 22 degrees, right? It can't go below that. That's the room temperature. And that's the idea. So anyways, let's just have a look at some more. If it's negative K, then that just means it's a decay question instead of a growth question. So it's negative KT. So you got to understand the same formula. It's just that if it's losing, it's negative K. If it's increasing, it's an exponent. It's a positive K. All right. Let's go again. I'll rather do a HSC question first, and then we'll come back to that one. All right. 2008 extension 1 HSC. Let's try this. A turkey is taken from the refrigerator. Its temperature is 5 degrees. When it is placed in an oven preheated to 190 degrees. So, you already know that, wait, I'll continue. Its temperature, T, after T hours in the oven, satisfies the equation D, capital T, which is temperature, on dt, time, equals negative K, T minus 190, where that is A, T minus A. So we know it says show that T equals this satisfies both this equation and the initial condition. Okay, so all you've got to do for I, you would obviously differentiate it, dt on dt. You bring the negative down, that becomes a positive k, so 185k, right? Negative k times negative 185 is positive 185k. E, negative kt. Now you can see they factorized a negative k out. So you're meant to factorize a negative k out. Then you're left with negative 185 e negative kt. And then what is negative 185 e negative kt equals to? Well, this negative 185 equals to t minus 190. So watch, t minus 190 equals negative 185 e. So this negative 185 equals to t minus 190. Let's see how I prove that. And then the idea with the initial condition is that dt is on dt is negative k t minus a, where a is 190, therefore satisfies initial conditions. How easy was that to say? So all they wanted to see is that you knew was negative k t minus a. Alright. Alright, I think it looks like I'll be spending about 3 or 4 weeks on this topic. We'll do a fair bit on this until we're really good at it. The turkey is placed into the oven at, okay, wait. Any questions firstly about that bit there? Alright, then the question that the equation we have is 190 take away 185 e negative kt. Cool? Alright. The turkey is placed into the oven at 9 a.m. At 10 a.m. the turkey reaches a temperature of 29 degrees. So when time is 1 hour, let's do it down here. When time is 1 hour, we know the temperature becomes 29. The turkey will be cooked when it reaches a temperature of 80 degrees. So temperature equals 80 degrees. We want to work out probably what the time is, I'm guessing. At what time to the nearest minute will it be cooked? Yep. All right, 3 marks. Let's do this. So what's the first thing I've got to do in this equation? What's the first thing that you got to usually find? Just like we did before. What's the first letter you've got to find?
K, right?
Think about it when you're going to say it again.
K.
Yeah, K. So I'm going to sub in time is 1, obviously, and then T is 29, and you'll have to find K first. You've got to find your constant. So first, so K. First, let's write that. First, find K. So T is 29, 190 minus 185, E negative K times T, so negative K times 1. Take away 190, divide by negative 185, log both sides, but let's do it one extra step there. .87, something like that, equals E negative K, log both sides. Bring the negative K down, divide by negative. So it'll be log 0.87 divided by negative 1. So log that answer, divide by negative 1. I got K equals 0.13895, let's say. Then find T. It's saying the perfect temperature for it is 80 degrees. So you would have to go 80 equals 190 minus 185 E negative. I like to write k because it's a bit annoying writing k each time like this. So I just write negative kt, and then we'll just start solving for t. Exactly the same. And you can get yourself 3 marks. So 80 take away 190 is negative 110. Divide by negative 185 is 0.5945. Blah 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 equals e negative kt. Log both sides. You're left with negative kt equals log of 0.5945. What do you do now with the negative k? And then t equals, just subbing k as that, of course. So log answer divided by negative k. .733. Question says, at what time to the nearest minute will it be cooked? 3 hours and 44 minutes. Now, let me tell you what I did. I did not sub in this K. You guys should know that by now. I subbed in this K, the original value. If you had subbed in this K, I don't think you would have got the 44 minutes. You might have got 43, might have got 45. I don't think you would have got 44 minutes. I don't know, actually. I'll check. I'll try it now just to see. 5945 divided by negative K, 0.13895. You get 3 hours and 45 minutes. So you get 3 hours and 45 minutes. If you did that, you would lose a mark. So please use your exact answers. Don't use your rounded answers. Ever. You can write it, just don't use it. Okay. Any questions? So the idea is always, when you've got an equation, you're going to find k. Once you find k, then they're going to ask you to find time. That's just literally every question. Find k, then find time. Find k, find time. Sometimes they ask you to find, the surrounding temperature or the initial temperature here. Easy. You're just going to type in time is 0 and you're done. But we'll do those ones on the top shortly. Okay, let's get to it. And by the way, this is true, right? So like if we're talking about, I don't know, if you're talking about serious fine dining restaurants and serious chefs around the world, they do use some serious mathematics to make sure they can cook their chickens, their turkeys, their steaks, whatever it is, to the perfect temperature, perfect consistency every single time. Now, if they themselves don't do it, obviously they've got models to actually do all this for them. So you can use it. You'll only ever use math in the real world if you want things perfect. So you can use math in the real world, you just got to know how to use it, I guess. But it's only used really for making things perfect if you wanted to. All right, here we go. In a kitchen where the temperature is 20 degrees. So that's constant air temperature. Stanley takes a kettle of boiling water off the stove at time 0. 5 minutes later, the temperature of the water is 70 degrees. Show that T satisfies the cooling equation of this. Okay, let's do it. So we're going to just differentiate. dt on dt equals, bring the k down, negative 80 k e negative kt. Again, you can see you want negative k, so that gives you negative k, open bracket, 80 e negative kt. What does AT E negative KT equal to? T minus 20. Which equals to negative K, T minus 20. Done. Satisfies the equation. B. Find the value of K. How do we find the value of K? So after that, you don't use the derivative, just so you guys know. It's just to satisfy the Coulomb equation. How do we find the values of K? What do you know? What do we know? We know 5 minutes later, the temperature of the water is 70 degrees. So we know when T equals to 5, T equals 70 degrees. Obviously, you got rid of little t, you'll get rid of big T, you're obviously going to solve for K. So it looks like this. Is anyone still not getting it? Am I going too fast? Sometimes I do go a bit fast when I don't need to for these bits. There, I don't know, you gotta let me know. Divide by 80. Maybe you guys are getting it. Log both sides. Divide by -5. And you'll get your answer. .094. Again, shift store A. I store it as A, so we write that, but we use the whole answer. Okay. Let's try C. How long will it take for the water temperature to drop to 25? See, how long? So you're trying to find time for the water temperature to be 25. So the capital T is 25. 25 equals 20 plus 80 E negative KT. You're going to find time. See how you're just doing the same question again and again and again. That's how it is. Once you start realizing it's the same question, it gets pretty easy. How do I get rid of the exponential? Log both sides. Then you've got negative K. How do I get rid of negative K? Divide by negative K. T equals log 5 on 80. Divide negative alpha A, which is 29.495. I go back up, I reread the question. How long will it take? T is in minutes. So it will take 29.495 minutes. Sketch the temperature to time function. Interesting. So sketch this. T equals 20 plus 80 E, doesn't matter what K is, negative T. All right. What are we going to do? E negative KT, I know is this way, right? Times it by 80 means that it's going cutting through 80. That would be 80 E negative KT. Plus 20 means shift the whole thing up 20. There's your 20. That's your asymptote. That's going to go through 100 now. Wondering how I knew that that's 80 or 100. You can just sub in time is 0. E to the 0 is 1. 80 times 1 is 80. 80 plus 20 is 100. So you'll just get 100 there. That stuff's easy. Easy. And as you can see, it kind of makes sense, you know, if you want to think of it in terms of boiling temperature, they started off at 100 and then slowly starts to get to our asymptote, which is our room temperature of 20 degrees. So eventually it will get to 20 degrees. As time approaches infinity, your temperature becomes 20 degrees. So it does make sense. Okay. Let's go Borkham Hills, extension 1. I'll let you guys I'll let you start it. So try to start with V, differentiate it, and try to get to this result. Try your best to get to that result. Okay, let's see. V equals 500 minus 500 E negative KT dV on dt equals, bring the negative K down, that becomes positive 500 K E negative KT. Again, we're trying to prove it's negative K, so you factorize negative K out, you almost force it out. You're left with negative 500 E negative KT. Negative 500 E negative KT would be V take away 500, and I think we've got it. V take away is a solution to this equation. To this equation, dV on dt equals negative K. As we get into year 12, when we say solution, it means integrate. So when it says like is a possible solution, so it's like the integral of this is this, or the derivative of this is that. That's what a solution means. Double A. The velocity after 5 seconds is 21. Find the value of K. Velocity is 21. T is 5. You just do it all again. Can you see how repetitive these questions are? It's a surprise that some students walk into their exams without getting marks for these. It's the same question. There you go. 21 Take away 500. Negative 479. Divide by negative 500. Log both sides. Then you're divided by negative 5. So log 479 over 500.
Same, but I thought you couldn't log a negative number.
No, you're logging this.
When you're logging 479,
Yeah, 479 on 500.
isn't it
The two
negative?
negatives disappeared, didn't they? Divide by negative.
Oh,
This is
yeah,
all over
over.
negative. Yeah. So it's log negative 475 over negative 500, but the negatives will just cancel out. And then k equals 0.0085815, blah, blah, blah. Alright, and then triple I, find the velocity after 20 seconds. Come on. Too easy. They're just easy questions. It's not that easy, it's like the concepts are easy. Negative k you already have, and t is 20. So negative k times 20. Well, actually, I might as well write k in this one because I realize there's no working out. You're just going to sub it into your calculator. So 500 minus 500 e negative answer times 20. Velocity is 78.85. Just plug it into your calculator. There's nothing to do there because it says find the velocity, v, and your time is 20. Explain the effect on the velocity as t becomes large. What does t becomes large mean? What does it mean by t is large? What number, what value is it trying to say?
Infinity, right?
Infinity. So as time approaches infinity, what's infinity times 0.00858? Ben, what's infinity times
Yes.
0.00858?
Infinity, right?
Times by negative
Wait.
1.
Wait,
You were right. Times by negative 1.
would it be negative infinity?
Correct. And then
No.
what's e
Oh, okay.
to the negative infinity?
That is, I don't know.
Okay. What happens to your exponential functions as it approaches negative infinity?
Oh, 0.
0. So e to the negative infinity, e to the negative infinity is 0. And what's 0 times 500?
0.
500 take away 0 is just 500. So the maximum velocity you'll get as time is very large is 500.
500.
Good job. In fact, all the time, I'll give you a clue. Every time you're going to see an infinity question that you've got to sub in for like all of the application questions, it's always going to be 0. They're not going to make you sub in infinity to make it infinity. All the infinity questions are going to become 0. So there's only 2 types of infinity questions. Here we go. Type 1, e to the negative infinity, which is 0, or 1 over infinity, which is 0. There's only 2 types that they'll ever give you, and they're both going to become 0. So if you ever see an application question that says sub in infinity, it's always going to just be 0. That's all you want to remember. But yeah, there you go. Okay. And another one, but I can't be bothered. Sydney Grammar. I'll leave that one for you guys to have a look through. At least to think about. Where are we up to? We've done all of exponential growth and decay. I am pretty happy with that. So now we're up to what everyone hates, which is the actual rates of change bit that's not applied. So the exponential, sorry, so just the numerical problems and stuff. Okay. Okay. So this one, exponential growth and decay, believe me when I tell you, easiest mark you're ever going to see in your extension papers. They're usually worth about 5 or 6 marks, but it's always that. Always the first question is prove that, second question is find K, then find temperature or find velocity, whatever it is, and then sometimes sketch, and that's pretty much it. They don't really get harder than that, which is good. So you can guarantee yourself 5 easy marks. These ones, I can't say the same about. You don't know which one you're going to get. So you don't know if it's going to be, in this case, a pontoon, or if it's going to be a sphere, or if it's going to be a sector of a circle, or if it's going to be a cone, or if it's going to be a looks like a triangle if it's a ladder leaning against the wall, or if it's going to be a cylinder and another triangle, well, if it's going to be a triangular prism, Toblerone thing, and it's got volume, so capacity as well, or if it's going to be a, does it make sense so far, what I'm trying to make you guys understand? Lamp, right, or it's going to be a lamp, velocity I think it was. Volume of a cube and surface area. So these are double spheres and volume, surface area. Purely algebraic expressions. These ones are really tricky and very poorly done. Hemispheres, cones, double cones. Yes, okay. Do we understand? So when I say it's hard, it is hard, right? The other one, it's easy. So you try to make sure, first thing, exponential growth and decay, I've got to get 4 marks. There is no room for error here in your exams. There can be some room for error here until you expose yourself with absolutely every question you can. There is no way you're going to get good at this until you do literally every question there is, because every question just differs by a little bit, and that kind of changes the math a lot. So these ones here, these rates of change style questions, so these numerical versions, or the shape, the geometry questions, are probably the most poorly attempted questions in the HSC. It's going to be hard for you guys. Like that, I'm just trying to tell you off the bat, this is not going to be done very well. It'll probably take us a few weeks to wrap our head around this. And it's okay. So don't be disheartened by it. Don't think it's going to be great from the beginning. I will make it as simple as I can, as always, but just this is the one. This is the one that you really want to spend a lot of time on to perfect, because you know a lot of students will do poorly. It's your time to shine. Here we go. There is a trick to it. So we'll start it off today, but there is a trick to it. There is a way to think about it. There are some clues that you can look out for and start to learn the style of question and what it's trying to say. But the best way about it, like I keep saying, is exposure. With this one specifically, you've got to expose because every question can differ, and that difference is already a big difference in terms of your math for these bits of rates of change. So let's start. Anyways, this is from the 2004 Extension 1 HSC, question 3. So not that difficult. But let's have a look at it. A ferry wharf consists of a floating pontoon linked to a jetty by a 4-meter long walkway. Let h meters be the difference in height between the top of the pontoon and the top of the jetty. Let x meters be the horizontal distance between the pontoon and the jetty. Very easy, first one. Find an expression for x in terms of h. What would you do? Find an expression for x in terms of h. What would you do?
4 squared minus h squared equals x squared.
Yeah, but let me make something clear. So Nadia just said, yeah, obviously simple Pythagoras. It doesn't mean just because I did Pythagoras here, I'm going to do Pythagoras ever again anywhere else, right? So it doesn't work like that. It's just, it's very specific to each question. And yeah, all right. I don't know what else to say just now. This used to be part of Year 12. So it's very interesting to teach it to Year 11 students. But let's go. Find an expression for x in terms of h. 16 minus h squared equals x squared. And of course, you get x equals plus minus root 16 take away h squared. So just use simple Pythagoras and you should get x in terms of h. You obviously know that x can't be negative, so x is going to be root 16 take away h squared. X must be greater than 0, it's distance. Double I. When the top of the pontoon is 1 meter lower than the top of the jetty, the tide is rising at a rate of 0.3 meters per hour. At what rate is the pontoon moving away from the jetty? When the top of the pontoon is 1 meter lower than the top of the jetty. When the top of the pontoon is 1 meter lower than the top of the jetty. So when that h is just 1, the tide is rising at a rate of 0.3 meters per hour. At what rate is the pontoon moving away from the jetty? So we want to find dx on dt. Okay, so the first thing you want to learn with rates of change is obviously the rate. What does rate mean? Rate means differentiate. So that's the first thing you want to learn. Right? Rate means derivative or differentiation. Why? Because I said it before, rates just means gradients. Gradients are derivatives. So when it says at what rate, it's talking about d on dt. At what rate is the pontoon moving away from the jetty? What letter would that be? D what on dt?
X.
dx. So you've got to find dx on dt. And the way we do these is that we write dx on the top and we multiply it by dt on the bottom. And the trick is, if I've got d of anything, let's call it ds, and I've got the ds as well, can you see how these two cross out and I'm back to dx on dt? So if I said again, if I went, I don't know, dA on dA, again, can you see how dA and dA cancel out, and that's actually allowed. So I'm allowed to break up dx on dt as dx on d something times d something on dt, as long as these two somethings are the same. Okay. Any questions about that? All right. Can anyone tell me then, what would these two letters be? You just
H.
went and, yes, H, smashed it. Well, the way you look at it is you just went and found X in terms of H. So it should be dx on dH, and then of course dH on dt, and that's where this comes in. The tide is rising at a rate of 0.3 meters per hour. So that means dH on dt, the tide is rising, is 0.3 meters. Right? So what's dx on dH? How do we find dx on dH? See how that's x in terms of h? So I can differentiate that. dx on dH is what? You bring the half down. 16, take away h squared, power of negative half, times by negative 2h, that's your chain rule, times dH on dt, which is 0.3. Do you guys get that, what I've just done there? dx on dH, which is derivative of this with respect to h. There it is. That's dx on dH. Times dH on dt, which is 0.3. And that's also a rate, and that's how you got to read that. That rate, straight away, you're like, oh, d, rising, dH, that's height, dH on dt. All right. And then, of course, you know, you can simplify this. Half times negative 2 is negative 1. So you get negative 0.3h on square root of 16 minus h squared. The question was, at what rate is the pontoon moving away from the jetty? The only thing you don't like is the fact that you still have h. You now know when the top of the pontoon is 1 meter lower than the top of the jetty. So when h equals what? When h equals 1, pontoon is 1 meter lower. So when h equals to 1, h equals to 1, dx on dt equals negative 0.3 on square root of 16 take away 1, which is root 15. And that would be the rate that the pontoon is moving away from the jetty. You know it's right because you actually got a negative, which means it's moving away. It's decreasing, whereas if it was moving closer, it would be an increasing. That's it. Meters per second, I'm guessing. Was it? Meters per hour. Sorry. Meters per hour. So the weird thing is just this bit here. You got to get your head around. So I'm going to stop from this booklet. I'm going to get to my booklet, which should just make things a little bit easier. So anyone still copying that down? Let's see. Where is it? Where is it? It would be rates of change, rates of change, rates of change, rates of change, year 12. Applications of differentiation, applications of calculus in the physical world. Calculus in the physical world. Calculus in the physical world, yep, that's great insert. Don't ever use OneNote. So your rates of change, very poorly done. It will take us, so rates of change is pretty much the foundation for us as well in extension 2 in mechanics. So you've got to be perfect at rates of change. So I'm not going to rush it. It won't be like a 2 lesson or 3 lesson. I think it looks like we're going to probably take at least 4 lessons on this to make sure we are perfect at rates of change. It combines everything, and that's why it used to be part of Year 12. It combines logs, exponentials, trig, calculus, algebra. It is pretty much the end of math because you're applying everything. At this stage of just rates of change, they're only applying logs and exponentials and some, not even trig because trig is part of the Year 12. But we will be doing trig as well. So we're going to be applying all of rates of change, even up to the Year 12 level. Once this thing goes in, oh, come on. It's taken 3 minutes and I've got nowhere with it. Serious. Now I'm just stuck. Please. It's not going to happen, is it? Stuff it. I'm closing this. Useless. 2020 year. What did I say? Year 12 advanced applications. Okay. I won't be able to write on this. But let me just see. How am I going to do this? I'm going to take a snapshot. Okay. Should work. Right. Very horribly, but it'll work. Okay. The rate of increase of a circle's radius is 0.2. meters per second. At what rate is its area increasing when the radius is 1.5? So, what are we trying to find? At what rate is its area increasing when the radius is 1.5? What are you trying to find? D what? On dt. So rate is going to be on time. We know that. At what rate is its area increasing? D what? What letter? Come on. No. Close.
Oh.
You do have, but you'll need that. Just wait. At what rate is its area increasing? D. dA. So you want to find dA on dt. Now it says the rate of increase of a circle's radius is 0.2. So what equals 0.2? D what?
dr on dt.
Yeah, that one. dr on dt is 0.2. The rate of increase of the radius is 0.2 meters per second. So technically, dA on dt, how can it be written? D what? dA on something times, you know, something on dt. And what do you think those two letters are going to be now?
dr.
dr. That's how we look at it, right? Now, dr and dt, sweet, you have that. dA on dr, you don't have. But it tells you what you want. You want an equation with A in terms of R. Any ideas?
Pi r squared.
Area circle, right? Pi R squared. So what's dA on dr now? Wait, let's stop for a second. See, that's the hardest bit. Where I got up to is the hardest bit that a lot of students just cannot start with. You've got to learn to do it the way I'm showing it to you. So I went all the way to the end of the question. It says, at what rate is the area increasing? That's the first thing I wrote, dA on dt. Then I know that that's dA on something and something on dt. These two letters would usually be what's given to you. The rate of increase of the circle is 0.2. So I know that dr on dt is 0.2. So I make these two into r's. Excuse me. Then when I've got that, I go, okay, well, I don't have a relationship between A and R for me to be able to actually differentiate that. So I need to have a relationship between A and R. And there it is. Once I've got that, the rest of what I'm going to do is easy. dA on dr, bring the 2 down. That's 2 pi r. Hey, look, circumference. dA on dr is 2 pi r. And you know that the radius is 1.5. So what's that? 3 pi. So therefore, dA on dt, the area is increasing at a rate of 3 pi times 0.2. And that's it. Easy. Let's just have a quick look at another one. No, I've already got the answers here for you guys. Quick look at one more. All right. The side length of a cube. The side length of a cube is increasing at a constant rate of 0.1 meters per second. The side length of a cube is increasing at a constant rate of 0.1 millimeters per second. Sorry. At what rate is its volume increasing when its volume is 8 millimeters cubed? What are we trying to find? At what rate is its volume increasing?
dV, right? Yeah.
Which equals to dV on. Now we want to pick out what letter this is. The side length of a cube is increasing at a rate of this. So that's ds, the side length. ds on dt is 0.1. So I know this is ds and this is ds. I need a relationship between volume and side. Do I have a relationship between volume of a cube and the side length of a cube?
It's just your thing to the power of 3.
It's just
the side
s
length
to the
too,
power
yeah.
3. That's exactly right. Volume is just side times side cubed. And then, of course, that's easy after that. So if you guys doing it the way I keep showing it to you, I can make it very, very easy. 3 times when it has volume of 8. Oh, so that's not 8. On ds is 3s squared, but when its volume is 8, side length is 2. So therefore this becomes 3 times 2 squared, which is 12. So that becomes 12 times 0.1. Becomes 1.2. Don't worry, we'll do a lot of these next week. But that's the basics that we need to be aware of. We need to be aware of that. dv on dt can be broken up into 2. Next week we're going to break it up into 3s as well, and we'll see how those work. I'll send you all your work. Stefan, Andy, to stay back for a little bit, please. Anyone else, if you've got any questions you want to ask, just stay back as well. Otherwise, I will see you next week.
Thank you, Sam.
You're welcome. Have a good night.
Thank you.
You're welcome.
Thanks, Sam.
Where are we? First we go here. 11. I'll stop recording first. Right.